Hi everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're chatting about outages at Cloudflare and Salesforce, as well as catching up with the global outage trends from the past couple of months. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On February 20th, customers using Cloudflare's Bring Your Own IP service experienced a service disruption. Can you start by explaining what Bring Your Own IP is, Mike?
Yeah, so normally when a business uses Cloudflare, the traffic runs over Cloudflare's own IP address space. Now, Bring Your Own IP sort of flips that around a bit. So it lets large customers bring their own IP address ranges to Cloudflare and then have Cloudflare originate and advertise those prefixes into the global routing table on their behalf. So from the outside world, those IPs look like they actually belong to the customer, but Cloudflare is actually sort of managing and distributing them. So it's not something then that all Cloudflare users would use. So it's a feature tier. And so why I'm saying this is it actually goes a long way to sort of explaining why this was relatively quiet in terms of public noise. Because the actual initial outage wouldn't have been necessarily attributed to Cloudflare. The affected organizations would have seen connectivity loss with what looked like their own IP address space or to their own sites. So the natural first response, therefore, is to sort of look inward at your own infrastructure, your upstream provider, those types of things. The Cloudflare connection then is not obvious because then we're not looking at that routing layer because that's handled by someone else. So a lot of the impact would have actually been absorbed quietly by NOC teams sort of investigating what they thought was their own problem. And then on top of that, if we're actually looking at from a reporting perspective, as in people going to somewhere and saying, is there an issue? They wouldn't have gone and said, is there an issue with Cloudflare? They'd have gone and said, is there an issue with customer A or customer B? Any sort of sentiment analysis would have been distributed across various areas. So we wouldn't have seen some sort of big boil up.
What was the nature of the problem here?
So it actually came down to a BGP route withdrawal. But this was actually triggered by an internal automated cleanup task, so some maintenance task. Cloudflare was running a process where they wanted to clean up unused Bring Your Own IP configurations, but it actually had a bug in it. So where there was an empty parameter, it actually interpreted as delete everything matching rather than delete nothing. So what it started doing was deleting these route advertisements. So therefore, it effectively had the subsequent effect of withdrawing these BGP route advertisements for these Bring Your Own IP prefixes. But by the time this actually identified by Cloudflare and they sort of manually stopped the process, they estimate around 1,100 prefixes out of roughly around 4,300 prefixes that have been pulled from the routing table. Now, the important thing to understand about what this means for the affected destinations is that those prefixes did not just become harder to reach, they cease to exist in the global routing table. You can't route around them. Something is being withdrawn. There's no alternate path to it. So what we then start to see is this thing called BGP path hunting, where we'll see the downstream providers or the downstream autonomous systems start going through this sequence where they're saying, oh, I know how to get to it. Can we get to it via you? Can we get to you via you? And they start to do this. So you see an origin destination, but traffic just routes through to this dead end, as it were.
Cloudflare managed to manually stop the faulty task, but only after a quarter of all BYO IP prefixes have been affected. What does this tell us about the speed with which faults can propagate?
So I want to be precise about this because it's easy to oversimplify. BGP propagation isn't instantaneous. So if it travels in a wave across the routing table, there's things like hold down timers, which mean withdrawn routes are not sort of flushed everywhere at once. So how quickly any given network sees the withdrawal depends on where it sits specifically within that topology and its peer relationships, how its time is configured. But what the data showed was the beginning of that process, as I said, we saw this path hunting behavior as the withdrawals started to ripple outwards. If you remember, we've had a series of Cloudflare outages through configuration changes where it sort of took stuff down. And over a period of time, they've instigated this process where they sort of do small parts. They hadn't actually gone through and withdrawn everything at once and done a wholesale change that contained any blast radius they had.
Why is an incident of this nature hard to diagnose quickly without the right monitoring tools?
So with the Bring Your Own IP, Cloudflare is originating and advertising their prefixes into global routing table on the customer's behalf. The customer has no BGP presence in this model at all. Now, this is kind of the whole point of the service. But what this then means is that from the outside world, those IP ranges simply appear to belong to the customer. So there's no visible Cloudflare fingerprint on destination address itself. So if your monitoring sees connectivity loss, what it actually looks like to a customer is the customer's owned IP range is gone. So your first instinct is to look at the customer's infrastructure, not the upstream provider, not Cloudflare. And that dependency is only visible if you're looking at that AS path and you know what you're looking at. So this is genuinely a tricky correlation problem, and is why some affected organizations would have spent some meaningful time looking at a different area before they actually isolated down. The path hunting itself, we saw very clearly in the data, is a direct consequence of a single homed architecture. So AS209242, which is the bring your own IP autonomous system, has only one upstream, which is the main Cloudflare one, which is autonomous system number 13335. So when those prefixes were withdrawn, the routing system had no illegitimate term. Now, what we saw in the internet is repeatedly generating, discarding of alternate paths, all of which still transit Cloudflare, because that was the only place where those prefixes can actually originate. Now, the routing system is essentially searching for something that does not exist, and that's showing exactly what the path hunting actually looks like. Now, looking at that from a holistic perspective, we were able to sort of correlate those and identify that common part in which they were all coming from that Cloudflare domain. And specifically, when we're seeing the ones that were directly affected, they resolved from the Cloudflare bring your own IP autonomous system. That allowed us to actually put things together. But if I was looking at individual service, I would only have seen that one service impacted. I wouldn't know what caused it. Only the fact is I actually couldn't get to that end destination.
What are the lessons to be learned from this outage?
So the first thing about this is automation scope. So when you give any automated process the ability to make broad destructive changes, you've got to have these sort of guardrails. You need to be able to proportion the actual blast radius. So if something does go wrong, you can actually sort of keep it quite contained. So this wasn't anything malicious going on. It was actually a cleanup task with a logic error. We've talked previously about this aspect where you have these cascading configuration issues, or I'm making one particular change, it can run out there. So the damage it caused in the time between it running the engine and stopping, whilst it was significant, there was the ability not to take everything out. The second learning is really about dependency visibility. Most enterprises have these third-party dependencies. They understand at a service level, but not necessarily at the infrastructure level. We know they use CDNs or different DNS providers. They have cloud network services, but they don't necessarily know how those dependencies are sort of plumbed together beneath the surface. So in this case, it specifically looked like customer infrastructure problem from anybody that wasn't looking specifically at that routing layer. So this is what we're going to call a hidden dependency. This isn't unique to the bring your own IP or even to Cloudflare. This is really persistent or endemic across enterprise infrastructure. So the idea is to be able to understand what's going on there. And the question worth asking after any incident like this is just not what broke, but what did I not know about my services and how they were connected to it before? Because that allows you to move forward to the next stage where I can sort of mitigate around it, or I can look at the seismic signals as something started coming in and then take action to mitigate it.
Salesforce experienced a global outage on March the 17th. What did you observe of this incident, Mike?
So what made this interesting was the way it actually failed. It had very specific sequence, and we can actually see this right across everywhere. So straight away, we can see this as a back-end issue. We start to see server-side errors, so we actually know we have network connectivity coming to back-end there. But what we actually were able to observe across a number of tests and across a number of instances of this was these HTTP 500 errors, so service unavailable types of things. But then it actually had a distinct pattern where it shifted to 503s across all the agents there. So this is normally, we'll see some going to 503s, some sort of sitting at 502s, and this distributed pattern. But this was kind of this straight switch over that we actually saw there. As it started to recover, we saw the pattern shift again, this time to go to receive timeouts. So the connections were still making their way through there, but there was actually nothing coming back. So why I say this was interesting was because this sequence didn't tell us it was just down. We could see that straight away, the fact there was error there. But as you gave us a readable story about sort of how it failed and some clues to what process in the back end might have actually caused this to fail.
The ThousandEyes platform data shows this was a lights on, lights off outage that lasted for 2.5 hours. Tell us why the combination of that data and 503 error messages make it possible to diagnose this as a back-end application failure.
What was healthy throughout? So we saw the DNS resolved clearly. We could actually get the name. We can see the TCP connections complete. We can even see sort of TLS handshakes succeeding. We knew that network path to Salesforce was fully functional the entire time. And it's also globally. If we think about how Salesforce is architected, we have these various instances from a regional perspective. But this was impacting everybody. Everywhere in the world, we're starting to see this. Now, if you then think about it from a 503 perspective, in this particular context, it's like a load balancer or a proxy was telling us that the backend is not available to serve traffic. So actually getting this system, we can't actually answer it there. And the fact, as I say this, is for every single agent globally hit this 503 at around the same sort of time across every region gave us sort of a key diagnostic there. That kind of rapid simultaneous convergence points to something more centralized, being taken out of service rather than a gradual failure or a regional failure. And certainly nothing from a network perspective. The past were there. So if it's been a network issue, a regional infrastructure problem, would have expected some geographic variation in timing, but in this case, there was none.
Why does the failure of the authentication layer specifically suggest a database tier issue?
When we say the authentication layer, what we're actually talking about is the serving of a very specific instance. So when you actually go to log on, you'll get this single sign-on page. So it'd be specific and customize your area there. Now, what we observed across multiple tests was the Salesforce single sign-on and that authentication handler, it effectively disappeared as a component. So I'm looking at it from a waterfall chart. So I can see that as the page loads, the component loads there. When I was actually looking at it from a failed state, this was consistently missing. So it wasn't called at all. The static content kept loading. So I could actually go to a generic Salesforce login page. The edge stuff was cached, but that never needs to touch the back end. I don't need to make that situation. But then the fact we saw that authentication handler missing tells us something else. That authentication component is dynamic, right? So it cannot be cached. So every request that it goes to must go to the back end directly. The authentication backends are among some of the most database read-intensive components in any platform. Every logon attempt, every session validation, every token check, it sort of requires a database lookup to look for permissions and things like that. So high volume, low latency, deeply sensitive to any degradation in the data tier. Any disruption to that, effectively, we're going to start to see this degradation in performance.
What does the appearance of a generic login page reveal about the failure?
It's actually a really clean indicator of where in the stack failure was concentrated. So when Salesforce is working normally, you see a customized sign-in branded page specific to your organization. And that customization requires this backend call to retrieve the org-specific configuration. Now, during the outage, what we observed across the test was a generic default login page, which doesn't require any backend call at all. So the system was falling back to whatever it was able to serve without actually sort of touching the broken component in the back end. So it's telling us that not just something is down, but to a degree, the component responsible for the personalized authentication is what effectively failed there. So everything that could be served statically or generically kept working, and everything required the back end did not.
Thanks for the deep dive into those outages, Mike. And now let's turn to the overall outage trends. What have we seen in recent weeks?
So the period we're looking at now runs quite a long period of time. So it runs from late January through to March 22nd. And the shape is really a tale of two halves. So we saw a gradual decline through most of February, where it actually bottomed out at around 239 outages. That was in the week of February the 16th to the 22nd, the lowest point in that whole observed period. Then the following week, things reversed sharply, where we saw a 62% jump. We jumped up to 386 outages globally, which was the highest weekly total we actually saw during the period. Now, the US mirrored that almost exactly. It was up 61% in the same week. What is worth noting, though, is that the spike appears to have been transient. It corrected quickly, and so by mid-March, we were back to levels sort of broadly consistent with where we'd been in the early period. One thing that stands out across the full period, though, is that the United States accounts for around half all observed outages globally. Now, this is a consistent pattern that we've seen over a period of time, but always sort of worth flagging.
You mentioned the US accounts for around half of all outages in this period. Is there anything else in the longer-term trend that stands out to you?
This is the one I find most interesting. So if you look at month over month, December to January and February were remarkably stable. Global outages sort of barely moved across all 3 months. Now, historically, that is not what we've seen. January and February typically become elevated activity. And this we've attributed to operators catching up on maintenance. Stuff was deferred over the holiday period. And then we have various maintenance tasks coming in one after the other. So we've seen typically this rise up through January there. And we've seen that pattern consistently in prior years, but this time it didn't materialize. Now, whether that reflects some generally changing in how network operators manage their maintenance cycles, or whether it's just an anomalous period, it's really hard to say at this moment in time. But it's different enough from prior years that I think it's worth watching to see whether it persists or not.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this help ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X @ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.